Hello, in this video, I'm going to talk about quantitative experimental methodology. So in experimental design, we have systematic manipulation of one or more variables to find out if those variables are affecting outcomes. Importantly, we hold other variables constant so that we're isolating the effects of the independent variables to see if those are what are causing the effects or the outcomes. Because of the design, we can generalize the findings in an experimental design to a broader population. Okay, so slipped a slide. Okay, so when we are planning experimental methodology, we need to make sure that we are hitting on these different points. So we need to talk about participants, and I'll go over each of these individually. Participants, variables, instrumentation and materials, experimental procedures, threats to validity, data analysis, and then interpreting the results and writing the discussion. So while you are planning your methodology and you are designing your study, writing your proposal, you need to make sure that you are addressing your plan for each of the things on this list. So for your participants, you need to describe the procedures for how you're going to recruit participants. So how are you recruiting these participants? Where are you finding them? When you select participants, are you doing it in a random way or non-random? So depending on just who's available, who volunteers. So of course, random selection would be preferable, but that isn't always possible. Sometimes we have to select participants because they have volunteered or they're available. And in that case, that would be non-random. So a true experimental design means that once you have your participants, that they are randomly assigned to the different treatment groups. And quasi-experimental design would mean that they're not randomly assigned, that the researcher has partial control or maybe no control over the participants' assignment to the different groups. So a true experimental design, of course, is preferable because then we can calculate the probability of participants being assigned in each group, and then we get stronger statistical results in the end. But in some cases, quasi-experimental design might be the only option depending on the nature of the experiment and the participants that you're working with. So we might measure second predictor variables. And we definitely need to conduct and report a power analysis so that we know how many participants we need to recruit and participate in our study to achieve statistical significance of the results. So when you're writing about your participants and how you plan to recruit and so on, you'll want to end that section with some kind of statement about the design, including how you're recruiting your participants. So it could be something along the lines of the experiment consisted or will consist of a one-way, two groups design comparing burnout symptoms between full-time and part-time nurses. So there you're delineating who your participants are. So in this case, it'd be full-time and part-time nurses, and you're indicating the type of study design. Then you'll also need to discuss your variables. So you need to identify the independent variable. So what is the thing that you are trying to test? You want to include a manipulation check measure. So during an experimental design, it's important that you be aware of how the participants are perceiving the manipulation of the independent variable. So a manipulation check measure is a measure, it's a check-in with the participants to see if they detected or perceived the manipulation of the variable. And if they did, what did they perceive? What was their perception of what was being tested in this study? So it's important to be aware of what the participants are perceiving as they're going through the study, because in some cases, in a lot of cases, the perception of the participants can certainly influence the results of the study. So it's important to know if they perceived it and what did they perceive. You also need to identify the dependent variables. So what do you think is going to be affected by the manipulation of the independent variables? Identify any other variables that you plan to measure, including demographics and things like that, and identify any potential confounding variables. So if there are any variables that you think could sort of mask the effects of the independent variables or be mistaken, where the outcomes we think are from the independent variables, but that might be a mistake and it really was from the confounding variables. So you want to identify those variables and make sure that you address that in your design so that you can protect against those confounders influencing your outcomes. Okay, instrumentation and materials. So you need to describe the instruments that the participants complete in the experiment. So it could be surveys, it could be other types of instruments, they could be instruments that the researchers use to assess the participants and whatever activities that are involved. So there will need to be some instruments of some kind that either the participants complete directly or the researchers are using to measure outcomes as you proceed through the study. So you need to identify those, discuss how they were developed, give credit to the sources where they came from, ask permission if, depending on who developed an instrument, make sure you ask permission to use that instrument. And then if it is an instrument that has been used, then you should be able to find the data about the reliability and validity. So bring that in and use that in support of that instrument. You might have to develop your own new instrument if one doesn't already exist that you need for your data collection. And in that case, you would need to probably pilot test it. And there are other methods for testing your own validity and reliability on your own instrument that you've developed. So it adds a lot of extra time and work when you're developing your own instruments, but in some cases that's the only way to proceed because you just need the right instrument, you need the correct instrument to measure the variables that you need to measure. You also want to thoroughly discuss the materials that are going to be used for the treatment itself. And in some experiments, there might be some amount of deception used. And so if there is, then you need a very complete and thorough cover story to explain what the participant is volunteering for and to explain to the participant what they're going to be experiencing. Without giving away whatever is the secret of the study that requires the deception. So when deception is used, it has to be with very good reason, and it has to be with minimal risk to the participant. And of course, the IRB is not going to approve a study that doesn't meet those standards. So if a study is approved that's using deception, then we can assume that that is ethical use of deception. Otherwise, it wouldn't have been approved. So we need to identify the type of experimental design that you plan to use. So pre-experimental, true experiment, quasi-experiment, single subject design. Identify what kind of comparisons that you tend to make between groups. So a within subject design means that you have a group of people that each experience all the different groups or all the different conditions, and then you're comparing with this one person who's gone through each condition, you're comparing the results of that one person to themselves. And then, of course, it's a whole group of people, not just one person, but you're comparing each person to themselves in the different conditions. Compared to a between subject design would mean that you have different groups of entirely different people. So you're comparing different people to one another who are receiving the different conditions. So there are different reasons why, sometimes a within subject design isn't going to work because there might be too much of an influence on which group which condition they experienced first. And in which case you might have different groups that are experiencing in different orders. But in some cases, it doesn't work to have the same person receive the different conditions. And in that case, you would then use a between subject design. And use a visual model to illustrate your research design if you can. That really makes it more readable, makes it easier for the reader to comprehend and sort of visualize the procedures and what is going to take place in the study. You need to consider any threats to validity of your study. So threats to internal validity, external validity, statistical conclusion validity, and construct validity. So threats to internal validity are like procedures, treatments, or experiences of the participants that threaten inferences in experiments. So like if your participants have had some kind of personal history, or if, let's say, they die in the middle of like a longitudinal study where it's taking place over time, and so you lose that participant. Or diffusion of treatment is when participants adopt a different intervention than the one they were assigned to. So maybe participants are put in the control group, but they're seeing that the treatment is working for the other group, and so they adopt that intervention when they're not supposed to. So that could be a problem. So those are just a few examples, but we've got to be careful of internal validity. External validity threats would be drawing incorrect inferences from sample data to other persons, settings, or situations. So this is a problem of generalizability. So if there is interaction of selection and treatment, so like the participants volunteered for the treatment, so that would make those participants different from other people in that population because they volunteered compared to others who did not volunteer. So they fundamentally might just be different. Or interaction of the setting and the treatment. So if the setting that the experiment is taking place in has an effect on the outcomes of the study, then we can't assume that those outcomes will also be the same if that same experiment is done in a different setting. And then also interaction of history and treatment. So we tend to make the assumption that if something happened a certain way in the past, that it will continue to happen that way in the future. But that is, of course, not always the case. So just because something happened a certain way doesn't mean it will always happen that same way. Statistical conclusion validity is if there's inadequate statistical power or violation of statistical assumptions. So inadequate statistical power is like you don't have enough participants. So maybe you started with enough participants, but over time, too many of them dropped out, or maybe depending on what you're studying, maybe too many participants passed away over the course of the study, but you might not have adequate statistical power, or violation of statistical assumptions. Like we assume that there's a normal distribution of certain traits among the participants in your group. And if it turns out that there isn't a normal distribution, that's an example of a violation of statistical assumption. Construct validity would be threats to construct validity would be if there's inadequate definitions and measures of variables. So maybe there are certain constructs or variables that you intend to measure, but maybe you're measuring the wrong thing. Maybe you intend to measure a certain thing and you're accidentally measuring a proxy, or you're measuring a different variable or construct entirely. Then that would be a threat to construct validity. All right, so the procedure of an experimental design. So you would start with some kind of pretest. You would start with some kind of baseline measure of the dependent variable that you want to see if it's going to change as a result of receiving the treatment. So you'd start with measuring the dependent variable, or at least a neighboring variable, something that's closely correlated. Then you have your group of participants, and you would match within your group of participants according to whatever traits are relevant to your to your experimental design, the thing that you're studying. So whatever it is that you're studying, there might be certain things that are relevant and others that really aren't. So you might be matching based on gender and age, or based on level of education, or fluency in a language, or whatever it might be, whatever is relevant to what you are studying. So you are matching your participants, and then one out of each pair will go into the control group and the other will go into the experimental treatment group. So that way you are making sure that your two groups or more groups, you could have groups of 3 that you then disperse into 3 groups. You're making sure that your groups are very similar or as similar as possible in that particular trait or characteristic of the participants that is relevant to what you're studying. So you would randomly assign from those pairs to go to the control or the experimental group. Then you would expose the experimental group to the treatment. Now, in some cases, you're also exposing the control group to a treatment. So it might be like the standard of care, or because it would be unethical to deny, like, let's say it's a patient of some kind who has a disease, we're not going to deny them treatment because they're in the control group. In that case, the control group might be whatever is the standard of care at the time compared to the other group that would be receiving an experimental treatment. Or in some cases, the control group would receive a certain treatment to enhance the validity of the results. Like let's say we want to test whether getting a weekly massage lowers blood pressure over time. So if we just had a control group who gets nothing and an experimental group who's getting a weekly massage, then let's say there are statistically significant results in the end saying that yes, getting a massage reduced blood pressure. We might be able to make the argument that it wasn't the massage that reduced blood pressure, because when you get a massage, you're in a quiet, dark room. You don't have any devices on you, or at least that you're looking at. You're listening to soothing music, you're laying down. So how can we know the massage is what did it? So by having the control group maybe lay on a dark, quiet room, listen to soothing music, close your eyes for an hour every week, it controls for those additional variables. And then if there is a significant result saying that, yes, the massage group did have lower blood pressure, then we could confidently say that that's because of the massage itself, not due just to the environment. And so then you would administer measures of the dependent variables. So like in my massage example, we're testing blood pressure. So we would have measured blood pressure at the very beginning, and then we would measure blood pressure probably throughout the experiment, but also especially at the end. And then you'd compare the performance of the experimental and control groups. So as you're writing your proposal, you want to make sure that you are planning for the data analysis. So you need a plan for how you're going to report the descriptive statistics. What inferential statistical tests are you going to use, and what types of relationships and things do you plan to detect? So you need to make sure that you're using the correct statistical tests to detect those relationships. And you want to report the confidence intervals and effect sizes in addition to what statistical tests you're going to be using. So how big was the effect, and how confident are you that that effect is accurate? And if you use a single subject design, you can use line graphs. So then you want to interpret the findings of your study in light of your hypotheses and questions. So you need to discuss, based on the findings, would you accept or reject your hypothesis, or did it answer your research question, and how so? So you want to go into depth there. And then why are the results significant or not? So there's statistical significance, and then there's also practical significance or clinical significance. So it could go either way. The results could be statistically significant, but in practical terms, it might not be very meaningful. Or the other way around, it might not be statistically significant, but in practical terms, it might be significant or relevant. So this is a place to discuss that and discuss what else has been found in the literature by previous authors. And where does your study and where do your results fit in the context and the landscape of the literature covering the area? And what are the implications? So is there something you would recommend changing in clinical practice or in professional practice, or not? And then also suggestions for future research. So as we conduct research, usually it just brings up more questions. We might be answering questions, but along the way, we come up with more questions. So you might have suggestions for maybe research that you might do yourself in the future, or for other researchers also to work toward in terms of answering those additional questions or building on the work that you've done here. All right, thank you so much for watching, and I'll see you in the next video.